Good morning, everybody. I know it's early, but I thought I'd join. I usually try to join the lectures a little bit early. So most of the times that you won't hear me talk until the class actually begins. But since it's the first class session, and I know a lot of you guys have some questions. So if you have questions, definitely you can feel free to ask right now. So if we might cover some of it during the class. So if you do ask a question that I'm going to cover later, I'll say we'll cover that in the class. But if you have questions just about the virtual teaching or anything about how's this semester going to work, definitely feel free to ask right now. So you can either turn on your microphone if you feel okay doing that, or you can type out the question in the chat and then I'll answer the question in the chat.
All right, sounds good. Good morning, by the way.
Morning. Also, this lecture and all the lectures this semester will be recorded. So basically what I do is I take the recording and I get kind of the raw video file and then I upload it to YouTube. So within 24 hours on the class website, you'll see the YouTube link for the lectures and you can view them at your convenience.
How's your summer going so far?
It was good until about a month ago, I would say. This month has been a little bit miserable for me because I've been sick for a lot of it. So I was kind of bedridden for the first 2 weeks in August, and then I felt better for about a week, and then now I've been feeling sick a little bit again too. So, but besides that, it's been a good summer. I'm very much an indoors kind of person, so I don't mind having to kind of stay indoors all day because I mostly just play video games and watch animes. But it's getting out occasionally, just to like maybe walk in the park or something has been nice. But I'm very glad to not have to deal with any traffic or anything. And I'm glad, that because of this, I know the virtual teaching kind of sucks in a lot of ways, but it's nice not to have to commute and I can stay in my pajamas all day. So that part is nice.
Right, I feel you.
Ever since we went virtual last semester, I feel like I spend like 16 hours a day sitting in this spot. So
yeah, I've been trying to find forms of exercise, mainly just walking. Really helps. At least calm yourself and distract yourself from what's going on.
Yeah, definitely. Yeah, anything you can do, I think, to get out is good.
Oh yeah.
How's your summer?
Yeah, it was pretty all right. A little boring, but I did what I could. Just mainly a lot of video games as well. A lot of movie watching, and I'm in a Gunpla, so I was building a few figures myself.
Nice. It's awesome. Yeah, so if you guys are just joining, I know we still have about 10 minutes until the lecture begins. So anything you guys want to ask about the class or the virtual teaching, definitely feel free to ask right now. So if you feel comfortable turning on your microphone, you can do that and ask the questions that way. Or you can send me you can either enter a public message in the chat or you can message me privately in the chat too. So if you do a public message in the chat, I'll probably answer the question out loud. But if you send me a private message, then I'll answer you privately in the chat. So welcome everybody.
You, Chris.
Oh.
Yeah, Professor. Hello.
Yes.
Good morning.
Good morning.
I took class with Chris. How you doing,
All
sir?
right.
Good. It feels like there's more than one person talking, so I can't really hear you. So
Right,
Steve.
I'll turn my mic up a little bit so you can hear me better.
Okay, yeah, that's much better. How are you?
Good. Just getting coffee. It's too early for me yet. I'm not used to my early morning routine again.
Yes, yeah, definitely. I think especially after the long summer, you know, waking up for an early class like this on the very first day is hard. I dusted off my alarm clock for the first time last night. But I basically hadn't used it the entire summer, so yeah, it's definitely definitely going to be a little bit. I'm usually a morning person, so it's not so bad for me, but it's you know, I know this is a pretty early time.
I had a summer course I took at the end of the summer, actually. So yeah, my class ended up not having a specific meeting time for a lecture. It was all agent pre-recorded lectures. So it all ended up being very, do it whenever you feel like it, which I actually didn't like as much. It makes it more difficult.
Yeah, I agree. I think, you know, even with the virtual instruction, I think it's good to have like, you know, a time and place, you know, where we can all meet up like this. So like, yes, I can pre-record all the lectures for the semester, but I think part of the learning experience is that, you know, if there's something you're confused about in the lecture, you can always stop me and ask me a question. So, you know, with you know, all the pre-recorded stuff, there's basically no way to do that. So
yeah, I definitely appreciate that a whole lot more than doing it pre-recorded. I mean, it's possible to do it. There's just something about the interaction, and then even having other students ask questions that you might not have thought to ask. So yeah, there's a bunch of different things.
Yeah, definitely.
All right, well, I'm going to get my coffee before we get set. And,
all right, sounds good.
See you guys in a few. Oh, by the way, Professor, did you happen to have like PowerPoints or PDFs or anything like that for like lecture notes that you're uploading to Canvas for us? Or
yes, yeah. So they're the lecture notes for this week are already uploaded on Canvas. I'll give you guys, you know, part of the plan for today is to give you a tour of the Canvas site, because I know Canvas is probably new for a lot. It's new for me too. So it's so I've set things up in a certain way, and you know, the nice thing about Canvas is that it gives us kind of a lot of flexibility on how to do things. So I just want to make sure you guys are familiar with that. But I have uploaded the lecture notes for this week, and I usually upload the lecture notes for the week on either Friday. Usually for this class, since this is the second time I'm teaching this, I'll probably upload the lecture notes on Friday, the week before, you know, we go over it the next week.
put them in the course outline.
Yes.
Okay. I see the link.
Yeah, so as we go throughout the semester, each of the weeks and the course outline will become clickable, and then you know, you can find the lecture notes for the week and just any assignments or any relevant files for that week as well. So yeah, I do plan to post all my lecture notes. Today I have a PowerPoint, but that's a rare thing. All the other lecture notes will be kind of PDFs of kind of the notes that I've written for the class. And I plan on uploading all of these solutions for all the homeworks and the exams as well.
Sorry for jumping the gun a bit, but I'm curious for homework and or lectures. Obviously, we're going to be uploading through PDF. Is it fine for me to work off my iPad and submit that as PDFs?
Oh, absolutely. Yeah.
Perfect. Just make
I was going to ask the same thing. I've got a Surface Pro 2 Surface Pro, like a tablet that I can write on, and I like to convert to PDF when I'm done.
Oh yeah, absolutely. As long as I can read it, that's the only thing that I care about. As long as I can read it, then you can do whatever you want.
Sounds good.
Sounds good to me.
Oh man, how's it going, Steve? Guess what?
What's it?
I upgraded to the Note 20 Ultra.
Nice.
Oh
Very
my
nice.
god, my wallet hates me right now.
I bet it does. But I bet your phone calls, emails, and everything else that you have going on.
Just a nice refresh rate of 120. I can't go 60 anymore.
That's funny. You got to do the. You got to do your Forza on your mobile.
Right.
Oh man. Yeah, I definitely need my coffee. I'll be back.
Hello, Professor.
Hi.
Okay, this is Jenny Ramos, your captioner.
Hi, Jenny. Yeah, great to meet you.
I'm sorry. I usually am not. I don't have a picture up there.
But, oh yeah. Well.
Nice to meet you. I just wanted to ask you, do you have my email so you can add me to whatever you're going to add, slides or whatever, just so I know what's going on with the class?
Oh, sure. Yes. You emailed me earlier this summer, so I should have that. I'll add you manually to the Canvas course so that you can you'll have access to all that stuff.
Okay, perfect. Nice meeting you, and have fun with this class.
Thanks. Yeah, nice meeting you too.
Alrighty.
So what were you playing during your summer, Professor?
I'm a big JRPG fan, so at the beginning of summer I played this series called Legend of Heroes: Trails of Cold Steel 3. So the third one just came out recently on Steam, so I played that one, and then I finally got around to playing Persona 5
nice.
in the middle of summer.
Yeah.
And then, but by the time I finished that, I got sick, so I haven't really played much since then.
That's understandable.
I've kind of started playing Ni no Kuni on Steam,
Nice.
but that's been going extremely slow just because I've been sick.
Yeah. No, yeah, I picked up Persona 5 Royals and I really enjoyed that one.
Nice.
Yeah. And then lately, I've been following. I'm into the new hotness, which is Fall Guys.
Nice. I've seen a lot of videos on that.
Yeah, it's really fun. It's not bad for $20.
All right, 30 more seconds. All right, it's 8:30, so let's go ahead and get started this morning. Welcome, everybody. So this is our first meeting, probably your first class of this very strange, fall semester. So, kind of, well, as you all know, just by the fact that we're on this Zoom call, this entire semester is going to be virtual. So, we tried this a little bit, at the end of the spring semester, but, having to do this for the entire semester, this is really uncharted territory. I think, we can do virtual instruction a little bit better than what we did in the spring, just because we kind of had the summer to prepare, but, it's still very much going to be a work in progress. So, I'm going to, of course, do my best. And, throughout the semester, I'm going to, ask for your guys' feedback and, just ways that we can make this better. Because, this might be, what we're doing. This could be what we're doing in the spring too. So, I know the virtual teaching in a lot of ways, it's going to be difficult just because of, you know, we don't have our face-to-face interaction, but just because it's difficult, I think doesn't mean it has to suck. So, you know, I really want to make this class, you know, as good and as useful as I can for all of you, okay? So welcome again. So this is EGME 333, so this is fluid mechanics. So I know this class has a bit of a reputation for being difficult, and you know, I'm not going to say that it's not going to be difficult. You know, it's definitely one of the harder classes that I teach here, and definitely I think, you know, you go to any program kind of around the country, and fluid mechanics is always kind of be kind of a one of those sticking points for people. So, you know, I'll save talking about the class because I have some introduction slides today just to kind of introduce what the class is, what a fluid is, and, you know, what you can kind of generally expect to learn. But, you know, before we really get started today, you know, I want to, you know, give you guys a chance to answer questions. So some of you guys asked questions before the class, but I know we've had a lot of people join since then. Because I know there's probably a lot of uncertainty, and there's a lot of, you know, things that, you know, you guys want to know before the class. So, so you know, before we get started today, I want to open the floor. Oh, I never introduced myself actually. So, so my name is Justin Tran. So, you know, you'll see a little bit more about me once we get to the lecture slides. So, you know, I'm usually, you know, pretty fine with whatever you call me. So, you know, I'm a pretty young guy, so I know it's kind of weird to call someone like me doctor or professor. So if you prefer to call me Justin, you know, I'm totally okay with that. You know, if you want to call me Professor or Dr. Tran, you know, basically anything's okay. I'm basically young enough to have grown up in the age of online gaming. So, you know, I've had people call me all kinds of terrible things online, and I've had people tell me all the terrible things that they've done to my mom, you know, last night over online games. So, you know, I'm used to it. But if you're going to call me something like Dickface or anything like that, maybe save that for our private correspondence. Don't turn on your mic in the middle of lecture and say, "Hey, Dickface." You know, I might not respond to you if you do that. So before we start, are there any questions just about this class, or, you know, about the virtual instruction, or anything like that? You can feel free, you know, if you feel comfortable, you can turn on your mic and ask a question. But if not, you can ask the question in the chat, and then I'll answer the question out loud.
Question. Camera, is that mandatory for attendance?
No. So, you know, if you stay as a black screen with your name, that's you know, that's fine for me. But if you feel comfortable, you know, definitely you can turn it on, but it's definitely not a requirement. So I set the Zoom setting so that, you know, when you join, your camera's off by default. So, you know, definitely feel free to leave it off if you want. Yep. So we have a question in the chat. So will I upload the lectures? Yes. So if you can see kind of in the top left corner of the lecture right now, you can see that it's recording. So every lecture is going to be recorded, and I'm going to basically download the lectures to my computer, and then I'm going to upload it to YouTube. So I like YouTube because it has kind of the automatic closed captioning, and it kind of stays there for forever. My YouTube channel gets more subscribers and views too, which is kind of a plus as well. But you can expect the lectures to be up on YouTube latest 24 hours after the lecture. So I basically work on downloading that and converting and uploading basically right after the lecture. Yeah. All right. So I have a question. When will homework be assigned and due? So so the lucky thing for you guys is that this is the second time that I've taught the class. So I have all the homework assignments that I developed from last year. They're not going to be completely the same. So don't go to Chegg and download the solutions and expect to just copy that. So I will change the problems around. But generally, I assign the homeworks in the middle of the week. So the homeworks will be assigned on Wednesday, and you'll have over a week to work on it. Yeah. So the pace that I usually go with is that, you know, before every exam that we'll have in this class, you'll have I'll try for 3 homework assignments so that, you know, you'll have basically plenty of time to practice the course material, you know, before we take the exam. But depending on the schedule, it might only be 2 homework assignments, but I try to squeeze basically 2 to 3 homework assignments in between each exam. So you kind of have those as reference to study for the exam. Yeah. All right, any more questions before we get started today? Okay.
I saw that you had posted a homework assignment already on our first page or whatever. Was that the one that you emailed us about?
Yes. Yeah. So the homework assignment that's on Canvas right now, it basically just reiterates, you know, the email introduction. So the first homework is going to be due this Friday. And basically all I want you to do is to send me an email just to introduce yourself. So I do this for all my classes. You know, for the students that have had me kind of previously, they find it kind of awkward because they said, you know, this is my third time introducing myself to you. But even for those students that, you know, you've had me previously, you're not the same person as you were, you know, last semester, or, you know, wherever the last time you had me as a, you know, as an instructor. So just, you know, just introduce yourself to me. So I gave you some questions just to kind of guide your response on the Canvas page. So you can use those questions if you want. But I just, you know, want to know just a little bit about you and, you know, what you're hoping to get from this class, just so, you know, I can tailor it as best as I can for you guys. So there's a question about office hours. So I'll go over office hours during the PowerPoint. So I think it'll be easier to kind of have it on there. So we'll go over it then. Okay, so let's go ahead and get started today. Okay, so this is so, you know, usually the way I start a lot of my classes, I start with the PowerPoint just because it's easier to kind of show pictures this way, and, you know, I have some videos that are embedded here. So so, you know, just like we mentioned at the beginning, this is EGME 333, the very first section. This is the very first lecture of that very first section, very early in the morning. Okay. So my name is, you know, Professor Justin Tran, but, you know, it is like, as I talked about before, you can call me kind of whatever you want. Okay. Okay. So here's just a little bit about myself. So, you know, I modified, usually I don't change the slide at all for, you know, for all my classes, but for this virtual semester, I had to change this a little bit. So my office is no longer on campus. It's still physically there, but, you know, I'm not allowed to be there. So my office is going to be in my apartment, which is, you know, what you see behind me. So my email is this, as you can see. So a lot of you have already sent me an email, so that's great. But if you ever forget my email, you know, it's very easy to remember because it looks like justran@fullerton.edu. So, you know, thankfully there's no running club at Fullerton that took this name because, you know, it's my name. But if you have trouble remembering, just think justran@fullerton.edu. So I grew up locally. So I grew up in Cypress, California. So if you don't know where that is, that's basically, you know, 8 miles west of here. You know, so well, now I don't do it so much because of COVID, but basically my parents are just basically right down the street. So I get to see them pretty often, which is very nice. And just a little bit of my research interests as I try to talk over the leaf blower that's going outside my apartment right now. Is that, you know, my research is actually very heavily in fluid mechanics. So what I do basically is I study basically the fluid mechanics of biological flows. So most notably blood flow. So I do simulations of blood flow to basically aid doctors and clinical researchers study things like cardiovascular disease or medical devices. And so to do that, you need some high performance computing. So that's basically running simulations on, you know, dozens of cores at the same time. So that usually requires, you know, a rack mounted server. You know, just by being here, I'm also just interested in good ways to teach science, technology, and engineering. Right. So I want to talk a little bit about today's learning objectives. So, you know, if you've had me before, you know that I love my learning objectives. So what these are basically are these are statements of, you know, you'll notice that all these statements here start with a verb. And that's by design. So what my goal is for these learning objectives is that these statements basically describe what you guys should be able to do, you know, after today's class. So you'll see that, you know, I have learning objectives for the week and for the class. So so a good way to basically test the knowledge yourself is to go through the learning objectives, you know, after the lecture or after you've done homework, and ask yourselves, like, can I do this? Can I describe what a fluid is? Can I list some applications for fluid mechanics? And if you can, you know, then you know, you got everything out of the lecture or out of the week that I wanted you to get. But if, you know, if that's something that you can't do, like you can't, you know, describe and explain what this density and viscosity is, then that's a good indication that, you know, maybe you should look back on the material or send me an email or come to office hours, and, you know, I want to make sure that you guys can do that. Okay, so let's start with kind of the most basic thing. So what is a fluid, right? So if you go to Wikipedia, which is, you know, the best source for kind of the, you know, the first things you want to learn about something. So Wikipedia basically says that in physics, a fluid is a substance that continuously deforms under an applied shear stress or external force. So, you know, for me, you know, this is a really good definition because this kind of scientifically kind of really describes what a fluid is, but I don't really like it all that much for your first kind of exposure to it because it's very wordy and it has a lot of you know, kind of technical terms. So I kind of went back to my you know, and kind of an 8th grade definition of a fluid, which you know, for me, I think this was kind of the first time that I really thought about what a fluid was. So from 8th grade science, and I know this because I still had my notes from 8th grade science class, but you know, the definition that I had there was that a fluid assumes the shape of the part of the container which it occupies, and it flows easily, right? So the key word there is kind of flows. So kind of the difference that you see between, you know, a liquid and a gas versus a solid is that, you know, a liquid and a gas, if you pour it out, then it kind of flows kind of in a very kind of smooth kind of way. And, you know, we'll spend basically most of this class kind of, you know, thinking of ways, you know, to basically mathematically and more precisely kind of define what it means to flow. But I think, you know, intuitively, I think that's one thing I want you guys to keep in mind is that, you know, we're going to be, this class is about things that flow. And I think, you know, just your kind of intuition about how water flows, how air flows, then I think that's kind of a really good starting point for this class. Okay, so what are some applications of fluid mechanics? So I think kind of the first one that I think, you know, comes to mind, and, you know, I think what a lot of people are generally interested is in the aerospace. You know, mostly on the aero side. So what you're looking at right here is a computation of fluid dynamics simulation of the airflow over an airplane. So this you know, could be a commercial airplane. I think this does look like a commercial airplane, right? And so, you know, in order to predict the airflow that goes over an airplane like this, you need to understand fluid mechanics. Because fluid mechanics is what's going to govern the kind of the direction and the velocity of the airflow that goes over, you know, a big structure like this. So without fluid mechanics, basically, you know, you can't do any kind of aerodynamics or any kind of airplane design or anything like that. So fluid mechanics plays a huge role in industries like this. So another area where fluid mechanics is really important is in public works. So what you're viewing here is a picture of the California aqueducts, which, you know, is responsible for routing water, you know, all around California. So as you can imagine, you know, all the piping and in the design of the canals and all that relies on a really intimate knowledge of fluid mechanics. So, you know, fluid mechanics is really important if you want to go into things like plumbing or public works or something like that, right? And, you know, I also wanted to give you guys kind of a more niche area. So this is, you know, of course, connected to my own past and my own research background. But there's a lot of, you know, flows of things that, you know, you don't really think about a lot. So here you can see the flow of blood through an aneurysm. So the aneurysm is basically given by this kind of bulbous sac right here, and you can see kind of the blood kind of recirculating there. But, you know, blood is a fluid just like water or air is, or, you know, some of the more traditional fluids. So it's going to obey all the same laws of conservation of mass and momentum. So, you know, all the methods that we learn in this class, you can actually apply them in biological context. And if you end up if you work for like a medical device company, you know, you'll see that they also rely really heavily on fluid mechanics to do their work because, you know, blood is a fluid as well. And so at this point, you know, I kind of want to stop and take a step back because, you know, I've been doing kind of most of the talking and kind of, you know, ask you guys. So, you know, just kind of 2 questions for you guys to think about. You know, where else do you see fluid mechanics in your daily life? And what other engineering applications of fluid mechanics can you think of? So, you know, usually at this point in the class, you know, I ask people to just kind of speak up and kind of, you know, answer the questions themselves. But, you know, I know turning on the mic is you know, a little bit scary for a lot of people. So if you want to shout something out, definitely shout it out. Or if you want to say in the chat, then you know, you can say in the chat as well. So I'll go ahead and open it up. So where do you guys see fluids in your daily life, and what other engineering applications of fluids do you know and are you interested in? All right, so in the chat we have, you know, hydraulic cylinders. So definitely, you know, any system that uses hydraulics, you know, is going to need fluid mechanics. So actually, you know, we'll be covering hydraulics very early in this class. So hydraulics has to do a lot with hydrostatics, which are, you know, fluids that don't move. So we'll be covering that starting next week. So, you know, a lot of the concepts that drive hydraulics are going to be driven by hydrostatics. Right? So in the chat, we also have a car cooling system. So absolutely. And the next one after that is airflow from the AC, definitely. So, you know, any kind of cooling system that relies on, you know, the flow of air or the flow of some kind of liquid or like a coolant in your car, that's definitely going to depend on fluid mechanics. So absolutely, that's a great application. So also in the chat, we also have coffee. So yes, coffee mechanics is very important. And coffee is a fluid just like any other. So that's definitely a good application there. I actually saw a very interesting study before about like, you know, different liquids in glasses basically. So what the study was that they put coffee, they put water, and they put beer in glasses next to each other. And they basically accelerated the glass and then they stopped it. And they basically chose the speed perfectly where like a couple of the fluids would overflow. Basically the coffee and the water would overflow, but the beer would not overflow. So they picked the speed like that directly. So so it was very interesting. I think, you know, not ultimately not practically useful, but it was very interesting and it produced a really cool video. Right? Okay, so we also have wind resistance from running, absolutely. So any kind of wind resistance that definitely relies on fluid mechanics. So we'll be going over wind resistance closer towards the end of the class. So when we go over drag and lift, that's definitely, you know, a concept where, you know, that's where wind resistance comes into play. So so we kind of need to kind of build up a lot of stuff before we get to that. You know, wind resistance is something that, you know, you would think is kind of easy to do, but, you know, it is actually quite complicated. So we're going to be building up towards that, but we're definitely going to be going over that towards the end. Right? So next we have airflow around a vehicle. So absolutely, that's definitely a great application for fluid mechanics. So you know, if you're into kind of sports car design, you've probably seen a lot of those kind of wind tunnel results where, you know, they put the car in a giant wind tunnel and they blow the wind over it, and they show you that the wind contours the vehicle really closely. So and you've probably seen some simulations like that as well. So the aerodynamics of vehicles is definitely something that's really important. So, you know, again, we'll be going over that once we go over drag and lift. Right? So we also have water mills harnessing water for energy. So, you know, that's a great kind of energy application for fluid mechanics as well. So definitely a great one. I hear someone's mic coming on every now and then. So did someone want to say something?
Well, since I'm interested in space, interesting things I find about fluid mechanics would be the fuel flow or the burn that happens when a rocket launches, for example.
Yeah, absolutely. Yeah, any kind of fuel system, you know, that has to deliver. So, you know, rockets definitely is a good one. Because, you know, the way that rockets work, they basically expel the fuel behind them, and just by that, just by conservation of momentum, you're expelling just a ton of fluid at high velocity. But that's what propels the rocket upward. So absolutely, there's a ton of fluid mechanics there as well. So that's definitely a great observation. All right, any others before we move on? That was really great. Yeah, thanks everybody. All right, one more. Okay. So thanks everyone. So that was really great. So I think one nice thing about the virtual class is that, you know, you can kind of type out your questions in the chat. I think that's a little bit easier to do than speaking out loud. So that was probably one of the best responses I've gotten to this. You know, well, I mean, I've only taught this one other time before, so you know, that was definitely really great. So thank you everybody. Okay, so let's move on. Okay, So now that we kind of have, you know, a good idea of what fluids are and kind of where it's applied, both in your everyday life and, you know, within engineering, you know, now let's kind of talk about, you know, what kinds of properties do fluids have. So, so fluids, you know, are the same as, you know, solids in that, you know, you can differentiate different kinds of fluids just based on their properties. So like your coffee is going to have different properties than your motor oil. And by properties, I mean, there's the chemical properties of, you know, one will probably kill you if you try to drink it and one will taste good. But there's a lot of, you know, other physical quantities that, or properties that we can talk about that relate to, you know, how's the fluid going to flow? And that's what we're mostly going to be concerned about with this class. So, you know, before we jump into some of the more important properties, I want to kind of make this distinction between intensive and extensive properties. So, you know, this is probably terms that you've heard about before, but I kind of wanted to go over it again and kind of wanted to give you kind of, you know, my definition of these, you know, because it's going to be important going forward, right? So typically when you think of, you know, the properties of a solid material, like, you know, you think of your chair, or you think of your desk, you think of your laptop, right? So, you know, usually we describe these in terms of extensive properties, like how much it weighs, like what its mass is, what its volume is, right? So the thing with extensive properties is that these depend on the amount of substance, right? So the amount of mass that's there. So your chair here has kind of a fixed amount of substance. Your desk here has a fixed amount of substance. You know, so it's kind of easy to describe in terms of extensive properties. So for fluids, you know, it's a little bit more difficult to describe in terms of extensive properties because fluids, you know, flow so much, and, you know, a lot of times you're going to be looking at, you know, what are the properties of this, you know, this motor oil as it flows throughout your engine, right? So if you want to talk about things, you know, just in a small section of your engine, it's a little bit hard because, you know, because the fluid flows, the amount of fluid that's in that space is something that's going to be changing quite rapidly. So a lot of times when we talk about properties of fluids, we want to talk about intensive properties. So intensive properties, they all have this this characteristic where, you know, the intensive properties don't change based on the amount of substance that you have. So if this glass right here was half filled with water, or if it was full of water, you know, the intensive properties of fluid are not going to change. You know, which is, I think when you say it like that, it sounds like kind of a weird concept, but, you know, to kind of illustrate this, I want to talk about kind of two, probably the most important properties that we're going to go over this class, and that's density and viscosity, right? Okay, so let's talk about density first. So density is kind of a way to characterize the mass of the fluid. So, so, you know, things are going to be measured in kilograms or grams. But what's different about density relative to mass is that it's a ratio. So it's the mass per unit volume. So you can see some typical units that you see here. So you have kilograms per meter cube. So that's kind of the standard SI unit for density. Or, you know, if you're talking about kind of a much lighter fluid, you might use grams per centimeter cube. So both of these are the same in that you have a mass and then you have a volume. So because this is a ratio, you know, this is an intensive property. So it doesn't matter if you have, you know, a glass half empty or a glass, you know, totally full of fluid, you know, its density is going to be the same, because if you divide the mass of that water divided by how much water you have, that ratio is going to be the same kind of no matter what. Okay? And so, you know, I think, you know, density is kind of easy to grasp because it's, you know, it's a concept you've seen before. But fluids that have higher density generally tend to be heavier than fluids with lower density, right? But as you'll see, you know, next week, density plays a really important role in hydrostatics. So specifically, you know, if you're familiar with the concept of buoyancy, which is determining whether things will float or not, then density is kind of the big determining factor for these things, right? And so just a small point of trivia, density generally does change with temperature. So if you heat up a fluid, then its you know, its density generally gets lower. So you're probably familiar with the phrase hot air rises. So and the reason for that is if you heat up air, then it becomes less dense. So that's basically how hot air balloons work. So you heat up the air inside the hot air balloon, it becomes less dense, so it becomes lighter, and you can lift off into the air. Okay, so to kind of illustrate that, I have a video that I want to show you. So I don't know if the sound is going to play. So so is the sound working? So do you guys hear kind of the goofy clown music and the guy narrating?
No.
It's
Okay.
No, it doesn't. I think when you share your screen, it gives you an option at the bottom to share with computer audio. I think that's why it's not.
Oh, okay, let me try that real quick. Oh, there we go. Okay, I see now. Okay, let's try this again. Oops.
Today, I'm going to show you a simple science experiment that you can try at home to learn about density. Start by taking an empty glass and tip in some water and food colouring. Then add some syrup or treacle.
Sorry. So was the sound working then?
Yeah, it was fine.
Okay. Let me go back to this. Get to hear the clown music several times.
Today, I'm going to show you a simple science experiment that you can try at home to learn about density. Start by taking an empty glass and tip in some water and food colouring. Then add some syrup or treacle. And I'm going to add a little bit more water to make the layer a bit thicker. Then finally, fill the glass up with some oil and leave it to settle for about 15 minutes. These liquids separate out into different layers because they're different densities and they don't mix. The syrup has the highest density, so it sits on the bottom, and the oil, which has the lowest density, rises to the top. Try dropping different objects in to see what happens. If we drop this metal nut in, which is really dense, you can see it sinks right to the bottom. But if I take this grape and drop it in, it sinks through the oil and water, but sits on the syrup. This is because the syrup is denser than the grape. Pretty cool, huh? Now if I take this plastic bottle top and drop it in, it slowly sinks through the oil and sits on the water. And finally, if I take this piece of sponge and drop it in, it sits on top. The oil is denser than the sponge. You can try dropping different objects in to see which fluids are denser. I also found shining a torch beam down from above gives a really nice effect. I hope you've enjoyed watching this video. If you want to see more, you can click on the links on the right-hand side, or take a look at my...
All right, so you can see there that density has a lot to do with it's going to determine a lot about buoyancy. So that's something we're going to be covering very soon. So you can see you'll see that a lot of what we cover in hydrostatics is going to depend on that. So density is a really important property of the fluid. Then that's one thing that I wanted to cover today for sure. And so what another way to kind of express density is to express things in terms of specific weight. And so, it's kind of a little bit of a scary term because it's specific weight, but it's actually, the way that you understand kind of force and mass, that's basically what how you understand specific weight. And so, if you want to compute weight from an object's mass, all you have to do is multiply by gravity. So for specific weight, you would just do the same thing, but with density. So the specific weight is usually given with this symbol, which is called a gamma here. So it kind of looks like a bow tie. And so in order to compute that, you just multiply density times gravity. And so the units for this are going to be force, which the SI unit for that is newtons per meter cubed. And so, we'll go over this later on too, but I just want to kind of introduce just the concept here. Right? And so the other, unit that unit that we'll see in hydrostatics is specific gravity, where one thing that's often compared in fluid mechanics is everyone's always interested in is will this thing float on water? So if I drop this glass in water, would it float on water? So one easy way to do that is basically just to compare the density of whatever object you have to the density of water. So specific gravity, you can see here, is a ratio between two densities. So it's the density of whatever object or whatever fluid that you're considering over the density of water. So this is really nice because just based on the specific gravity, if it's greater than 1, so basically if the density of your object is more than water, then your object will sink in water. But if the specific gravity is less than 1, which means that your object is less dense than water, then your object will float. So if you're interested in seeing whether things will float in water or not, then specific gravity is kind of the way that you go about this. Okay, so that's density. So the other kind of really big property that we'll go over that we won't see this until we get to maybe go halfway through the semester, but this is a really important property of the fluid. It's called viscosity. So I think people, people have generally heard the term viscosity before. So generally, things like honey, which is, a very kind of a thick fluid. It takes a while to, pour honey from from the bottle. That's a fluid with high viscosity. So, we'll be covering kind of a more precise definition later, but I think for now it's good to just think of viscosity as characterizing how well a fluid resists flowing, right? So honey, which is a very viscous fluid, it really resists flowing. Like you have to squeeze the bottle really hard in order to get the honey to come out because it has a high viscosity. You compare that to a fluid with low viscosity like water, and all you have to do to get water all over your carpet is just to kind of like turn a water bottle upside down. And I actually had water in there, so I just spilled on my desk, but that's okay. And so kind of, intuitively speaking, fluids with higher viscosity tend to, they feel stickier, they feel thicker. If you try to run your hand through like a cup of water, you pull it out and you just dry your hand off. But if you run your hand through a cup of honey, then, it's going to feel really kind of sticky and it feels really thick, and it's, not, some people were into that, but, for me, I don't really like that all that much, right? And so kind of a more, precise definition of viscosity, just for now, is that viscosity describes how well a fluid resists any forces that are acted upon it, right? And so I have a video for viscosity. So this one has some sound, but it also has the text. So just to kind of illustrate, how viscosity works a little bit. So you can see from that experiment, they basically measured viscosity by measuring how long it took the marble to go down, right? So for the more viscous fluids, those are the ones that resisted more of the marble coming into it. So things like the syrup and the honey, have higher viscosity because it took the marble a lot longer for it to fall to the bottom, right? Okay. So the units for viscosity are a little bit complicated, and what you'll see later on is that there are basically two kinds of viscosities. So there's dynamic viscosity, which I think this is kind of generally the more useful unit for if you're doing kind of practical engineering work with viscosity. So the units for this are going to be Pascal seconds, or another way to describe this is kilograms over meter second, right? But another unit for viscosity, which you can obtain by taking dynamic viscosity and you divide it by the density, is the kinematic viscosity. So the reason it's called kinematic is because we're missing any kind of mass or any kind of force here. So the units for kinematic viscosity, which look actually really weird the first time you see it, is meters squared per second, right? So both of these are the same. It's just the way that you convert between them is just you multiply by the density of the fluid. But you might see both of these, if you're looking up the viscosity of a fluid. So I want to make sure that you guys, are exposed to that. Okay. Okay. So why are fluid mechanics important? So we talked a bit about this at the beginning, but fluids form a core part of a lot of engineering systems. We talked about airplanes, we talked about car engines, water pipes, medical devices. basically any kind of engineering system that has fluid either flowing over it or flowing through it, you know, you're going to need to know fluid mechanics in order to work with those kinds of devices, right? You know, if you're working in the area of design, you know, there's countless new devices and improvements that are, you know, basically just waiting to be discovered by, you know, the next generation of fluids engineers. And the thing with fluids is that, you know, you'll see that this class is difficult. So, you know, whenever you have a difficult subject like this, you know, people are kind of discovering something new about fluids all the time, or different, or, you know, kind of clever ways to use fluids. So I'd say, you know, the potential to design, you know, better fluid systems is huge out there. So, you know, this class will help you do that. Okay, so the next thing I want to do is I just wanted to give just a very brief overview of the class. So I'm basically going to be building a kind of a bubble diagram. So here's, you know, in the middle here you have fluid mechanics, which is the title of the course. And around this I have kind of what I think are kind of the 4 big core areas that we're going to cover. So we're going to start on the left here with fluid statics. And you know, with fluid properties, we covered a little bit of that today, but we'll do more of that maybe later today, but definitely on Wednesday. And then from there we'll go to fluid dynamics and dimensional analysis. Okay? And we can blow this up another level. So this is basically all the topics that I planned for this class. So this is not supposed to make sense right now, but you know, as we go throughout the semester, basically we'll be able to basically cross off areas in this chart. So and these are basically how I think a lot of these concepts are related to each other. So, you know, even though we're going to be starting with fluid statics, you know, there's some concepts from other parts of the class that you can see will connect there too. So fluid mechanics is, you know, it's definitely a very broad subject, and it's very interconnected too, and that a lot of the topics and a lot of the areas will definitely, you know, relate back to each other. So, you know, just because, you know, when we're done with the fluid statics part doesn't mean you can kind of throw it away, because, you know, a lot of those concepts and a lot of those, that knowledge, you know, we'll be building upon it for the rest of the class too. So definitely keep that in mind as we go about the class. Okay, so are there any questions on just fluids in general, or just, you know, or the course structure before we start going over the syllabus? Okay, so let's go over the syllabus. Okay? So this, you know, normally, you know, in the class I pass out a syllabus for everyone, but you know, because we're virtual, you know, you can follow along from the course website. So from the homepage on the Canvas site, you know, you should see a link to download the syllabus, and you can follow along. Or if you just want to listen, you know, you can just listen. You know, this session is going to be recorded, so you can definitely come back to this and, you know, read the syllabus at your own leisure. Okay. Okay, so first let's talk office hours. I know there was a question at the beginning for office hours. So, you know, this semester is going to be virtual, so there's no physical location for the office hours, but it's all going to take place on Zoom. So each of these office hours will have a different Zoom link. So basically, you just have to click the link and you can join on that Zoom call. Okay, and all those Zoom links are posted on Canvas, which is the course website. Okay. So I have 3 office hours, so you can see I tried to vary them on different days, and I tried to vary the times. And the reason I do this is basically to basically try to make it so that everyone can try to make would be able to make at least 1 office hour. So I try to hold you know, 1 more office hour sessions than normal, and I try to vary the times in the days so that, you know, hopefully there's at least one that works for everyone. So our first office hours will actually be right after the class. So the first office hour will be on Mondays from 10 a.m. to 11:30 a.m. There's another office hours on Tuesday, which is tomorrow in the afternoon, which is from 2:30 p.m. to 4 p.m. And there's also office hours on Thursdays, and this is going to be in the evenings, from 4 p.m. to 5:30 p.m. Okay? You know, just like they always are in person, you know, just having a virtual doesn't make any difference. So office hours are for, you know, if there's anything that's confusing about the course content, or if you have questions on the homework or questions on the exam, you know, definitely pop into office hours and ask those things. So, you know, I'm always happy to help with these things, and you know, my goal is to have everyone succeed in the class. So if there's anything that's ever confusing to you, you know, and if you've had me for as an instructor before, you know, I make some mistakes on the homework solutions as well. So definitely, you know, pop into office hours or send me an email to clarify those things, and I'm always happy to answer. Or, you know, if you want to just pop into office hours just to introduce yourself, you know, I'm always happy to chat about that as well. So, you know, office hours are generally for those things. Okay. Okay, so let's talk learning objectives. So we talked about this at the beginning about having, you know, learning objectives for the day and learning objectives for the week, but, you know, we also have learning objectives for the course, right? And so the idea with these course level learning objectives is that, you know, these are things that I want you guys to be able to say that you can do by the time you reach the end of the course, right? So we have 6 learning objectives here. So we covered a little bit of the first one today. So just to, you know, define a food in terms of its properties and how it moves. And, you know, probably a lot of these other learning objectives, they don't make sense right now. And they don't make sense because we haven't got to them yet. So, but, you know, the goal for this class is to basically cover all these learning objectives to make sure that you guys can do these by the end of the class, right? And I basically, you know, these learning objectives are, you know, I use them basically as basically kind of like the North Stars for this class. So I try to organize the class such that, you know, everything that we do in the lecture and everything that I ask you guys to do on the homeworks and the exams will align with these learning objectives in one way or the other. So I find that it's useful like that, so that, you know, we don't kind of get off track, or I don't ask you to do something that's unreasonable. So, you know, everything, I try to make sure that everything that we do is guided by these learning objectives, just so, you know, you guys get the most out of the class and the class kind of stays as organized as it can be. Okay, so homeworks and exams. So right now there's the plans to have 9 homework assignments. So that includes the introduction homework assignment that I gave today. So kind of like what I talked about at the beginning, I try to make it so that there are 2 homework assignments before each, 2 or 3 homework assignments before each exam, just to kind of give you guys practice. Okay. And so a little bit about the homeworks. So I always make it so that I drop the lowest homework grade, just because, you know, I know, you know, things happen throughout the semester, and you know, it's a long semester, and I know it's, you know, it's not the easiest thing to, you know, keep up with all the homeworks, especially, you know, my homework assignments tend to be a little bit long. So, you know, I want to give you guys a little bit of leeway, but, you know, I designed these homework assignments to give you guys kind of crucial practice for the exam. So kind of my philosophy with homeworks and the exams is I tend to assign kind of long and difficult homework assignments. And kind of the reason I do that is because, you know, homeworks, you kind of have a lot of time to do them, so you can really think about it and work through the problems. But the exams kind of tend to be a much more stressful environment. So I usually, you know, write my exam problems kind of like one level down from the homework. So I always tell my students that, you know, if you can work through the homeworks, you know, and the homeworks are, you know, difficult, then you'll do just fine for the exams, because I write the exams to kind of be easier than the homeworks. So even though I dropped the lowest homework assignment, you know, I want to ask that you please do them all, because, you know, they're going to give you guys, you know, the practice and the that you're going to need for the exams, right? Okay, so the next thing is, you know, the midterm exams, they're not going to be cumulative. So the midterm exams are basically just going to be covering the last, you know, 4, 5, 6 weeks that we covered in the lecture. So by the time we get to the second midterm, you know, none of the first midterm stuff will explicitly on it. But the final exam will be cumulative. And these are the dates that I have planned for the exam. I think that's our time slot for the exam, but for the final exam. But you know, I know that, you know, we're taking all these virtually, so it's not really a simple matter of me kind of collecting a paper exam. Basically my plan is to basically give you guys extra time on the exam, so that you have time to basically scan your work, or, you know, if you're working on your iPad, to convert to PDF and upload onto campus. So so right now what I'm thinking of is to give you guys basically 2x time. But what I did last semester was I gave everyone basically 24 hours to do the exam. Just to kind of give everyone flexibility, and, you know, and that worked out pretty well. So I might do that too, but there were some issues with that as well. So I do want to try cutting it down, but I don't want to cut it down such that it's you know, it's a burden for you guys. And I think the 3-hour thing is a little bit difficult, because I know some of you guys have classes after this, and like I don't want you to miss that class for this exam as well. So you know, we'll talk about this as you know, as we get closer to the exam. Okay, so course grades. So this is basically how I have the course grades broken down. So homework's going to be worth 20%. Each of the midterm exams will also be worth 20%, and the final exam will be 40%. So everything's in nice kind of increments of 20%. Okay? And then, you know, based on your kind of your grade point, or your or basically the percentage that you have in the class, this is how it's going to be. This is how the letter grades are going to be assigned. Okay. I usually don't do a straight scale like this. So I usually make it so that I scale the grades at the end. So basically what I'll do is that, you know, if the class average is kind of lower than kind of what I want, then what I'll do is I'll add a flat amount of points to everyone's grade such that the average is, you know, up to little over about 75%. That's usually what I want my class average to be. So, you know, if the class average by the end is 70%, then you can add 5 points to your grade. And then depending on where you fall after that, you know, these are the letter grades that are going to be assigned. Okay. Okay. So are there any questions about, you know, the kind of the grades, or just anything that we've covered in the syllabus so far?
I got an email right before you started with the syllabus stuff or whatever that it talked about. It was from IT, and I saw it on the news before we just jumped in or whatever, that Zoom has been crashing for a lot of people. Obviously, because the first day, everybody and their mother jumping on it and stuff like that. Do we have a backup or something else that you have set up that we should be aware of in case our live lectures somehow dies on us mid-stride?
Yeah, that's a good question. Yeah, that's a great question. I don't have an explicit backup right now, but I think that's definitely a great idea for me to do. So we have our Discord server, you know, which I know there's been some issues with. So, you know, I'll talk about that later. So, you know, once I kind of fix the Discord server, we can have lectures on Discord. The nice thing about this class is that there's you know, not too many of us. So I think we should all fit into a Discord server. But I know there's different services like Google Classroom. I know Microsoft has a service too, where I think you're right, where in case Zoom kind of goes down on us, it would be good to have kind of a backup plan. So let me look into that, and then I'll have news about that by the next time that we meet.
And your Discord server, like I tested it out this morning and posted like an introduction or whatever, but it seemed to be accepting, and I get announcements whenever people join the channel, so it seems to be notifying you properly.
Okay, that's good. That's good. Yeah, we'll talk about the Discord server in a little bit. But it's good. It's good that you were able to post today. Okay, so the course textbook, it's required for this class. It's a good textbook. It's actually the exact same textbook that I used when I took fluid mechanics a long time ago. I actually have it with me, you know, down there, although I have an older version of it. So definitely, you know, pick it up if you can. But you know, I'm not explicit. You know, it's not important that you get this edition. So if you know, honestly, if you ask me, I would tell you that the textbook industry in America is run by the mafia. And so, you know, generally, I don't supporting the mafia at any given time. So if you can find like a much cheaper version of the textbook, or even a free version that you can download, you know, you should definitely, you know, look into those options. I think especially with the virtual instruction, if you have kind of a PDF version of the textbook, I think that's something that's kind of nice that you can kind of follow along with the lectures too. Okay? So you won't need the textbook explicitly, because, you know, when I write my homework assignments, I tend to write out kind of the full problem on the homework PDF itself. So you don't need to reference the textbook for any of the homework assignments. But it is kind of a really good reference where, you know, the lecture notes that I post will follow the textbook pretty closely, but, you know, of course the textbook is going to have a lot more detail and some more examples that I don't have time to cover in the class. So if you can pick it up, you know, it's definitely going to be a great reference. I think professionally it's going to be a great reference to, you know, if you end up doing work with fluid mechanics. But, you know, it doesn't have to be this edition, so try to find as cheap a version of it as you can. Okay, so we'll take kind of a tour of the course website later, but basically what you can expect from the Canvas site is that, you know, I'm going to be posting all the lecture notes and all the lecture slides that, you know, I'll be covering in the class, all the homework assignments, homework solutions, exam solutions, study guides. Basically any material that I produce for the class is going to be on Canvas. And, for this virtual class, I'm also going to be posting the lecture recordings on Canvas as well. We'll do a little bit of it today, but, starting Wednesday, the way I'll be doing lectures, I'll be basically writing the notes live. So I'll be uploading those live lecture notes as well. Okay? And so Canvas will also be kind of the main way that I'm going to be communicating with you guys. So I'm going to be making announcements on the Canvas site. And it's good to see that was working, because hopefully you guys all got the announcement email that I sent yesterday. Okay? And so one other thing that I've made for this class, kind of special because it's a virtual class, is the Discord server. So I think one thing that we're lacking the most with this virtual instruction is that we don't have the physical classroom. So I think what's nice about the physical classroom is that we all kind of get together on the first day, and you kind of meet your peers in the class. Hi, my name is Justin. Do you want to study together for this class? But for the virtual instruction, we don't have that, because we kind of have this Zoom setup where everyone is kind of everyone's kind of far away in their own home. So I feel like interaction will be difficult. So basically, the idea with the Discord server is basically just to give you guys kind of a place to interact with each other kind of in an informal setting, right? So that Discord server it's mostly just for you guys. So so hopefully what you guys will see is that there's channels there where you can ask questions about the class. Say you're stuck on a homework assignment, or you don't get a certain part of the lecture, and you guys can use that server to answer each other's questions. So I'll pop in every now and then, but I really want that to be kind of a space for you guys to to discuss about the class, and organize study groups, and share memes about the class. You can share memes making fun of me. That's totally fine too. But I basically wanted to give you guys a space to interact with the class yourself. But I'll pop in sometimes. I'll pop in usually on the questions channel. So if there's a question that a lot of people have about the homeworks, and people are not sure about the answer, I'll pop in and answer those questions. But I won't be checking it all the time. So that Discord server is for you guys. Okay. And what you guys probably noticed is that I set pretty strict security on the Discord server. So I made it so that you had to be a member of the server for 10 minutes before you can post anything, and I have to assign you a role in order to post anything. So I did that because I didn't want trolls to basically join the server halfway through the semester and kind of just mess up the channel. So it'll take a little bit after you join the server before you can post anything, but basically I set that just so that we don't have trolls joining the server halfway through the semester. Okay, course policies. So the first thing I want to talk about is late homework. So I do accept late homeworks, but there is going to be a penalty for it. So basically if you do turn in homework late, I basically dock 10% off the points for each day that it's late. But that's better than not turning it in at all. So definitely take advantage of that if you had a busy week or something like that. Okay. So the next sentence doesn't really apply because we're submitting everything electronically on Canvas anyway. But if you're having trouble with the Canvas submission, you can always email your homework to me directly, and I can grade that as well. Okay. So regrades. So I'm not the perfect grader, so I make mistakes on that stuff all the time. So definitely if you feel like I made a mistake on grading your homework for the exams, definitely let me know. But you basically only have a week to do that. And so, don't come to me in the last week of the semester to say you want to regrade on midterm 1, because that's basically gonna be way too late. And so the reason I do this is, when I grade your stuff, when I grade your homework, I grade your exams. I try to make it so that I leave you comments, and I kind of point out the areas where where you made the mistake. So I gave you feedback that I want you to read. And so that you would improve on this for next time. So I want you to be reading that kind of in a timely manner. Like, I don't want you to get your exam back and then just kind of stow it away to the back burner, and then bring it out when you need a few more points for your grade. So I want you guys to be reading that feedback basically as soon as you get it, because I think that's when it's going to be most useful to you. And so to kind of encourage that, basically I make it so that if you want to regrade on anything, you basically have to come to me within a week of when I return it to you in order to get a regrade. Right? Okay, so email. So this one's really important. So especially, you know, because this is kind of going to be probably the primary way that you're going to contact me. So when you email me about anything in the class, please include the class or the tag EGME 333 in the subject line of the email, just so I kind of know right away what class that you're asking me about. So I'm teaching 3 different classes this semester, so you know I have there's a lot of you guys that I'm teaching, so it really helps me a lot to kind of know you know what class that you're in kind of right away, so that I kind of you know can kind of narrow my focus, you know, say like, okay, this is going to be a question about fluids. So you know that really helps me when you put that in the subject line. You know, I'll still read your email and answer you even if you don't do that, but it really does help me a lot when you do tell me what class that you're in. Okay? And so, you know, I usually try to be my best, do my best with the email. So I'll respond to you usually within 48 hours, except on the weekend. So, you know, a lot of you guys have been sending me your introduction email. So I've been trying to respond to that. I'm a little bit behind just because I had to sleep early last night because I was sick. But I'll be working on answering those throughout today as well. Okay, academic dishonesty. So this is, you know, not my favorite discussion to have every semester, but you know, it's a really important one. But you know, academic dishonesty, you know, just like any course, you know, it's not going to be tolerated in this course. So, you know, if you do commit academic dishonesty, you know, at the very least, what's going to happen is that you're going to get a 0 on that assignment. You know, and I might have to refer you to, you know, student conduct, and you know, if it's on an exam or something, you know, you could just fail the course. So, so this is a little bit strange, you know, just because you know we're going to be virtual this semester. You know, and you know, one thing that I'll have for the exam is that you know you can use your notes and your books, you know, for all the exams. You know, because basically there's no way for me to police that. But you know, one thing that I do ask is that you know for the exams, you know, please just don't talk to anyone else in the class about it. You know, I want you guys to do the exams yourself. And you know, the reason I do this is you know, basically every time that you cheat or you know you copy off someone, it takes away from your learning. You know, and you know, I don't want this class to just be something that you know I earned a grade at, you know, and then I'm kind of done with it. You know, I want this class to, you know, to teach you guys something valuable that you're going to use in your careers. And, you know, and basically what's happening is that if you're cheating, you're not, you know, you're not maximizing your time in this class. So, you know, if you ever do find yourself that you're struggling in the class or you're not really sure what's going on, just please, you know, before your result of cheating, just give me a chance to kind of help you out first. So, you know, send me an email, you know, pop into office hours, you know, just saying, you know, I have no idea what's going on. Like, can you help me? You know, and I want to have that opportunity to help you guys before, you know, any cheating does occur. Because, you know, I really believe that my job here is to, you know, help everyone here succeed and make the most of their time here at Fullerton, and, you know, just to, you know, make sure that your professional lives after this are going to be successful too. So, you know, you can email me like, you know, 15 minutes before the exam and say like, I have no idea what's going on. You know, I'm really scared for this exam. You know, and I'm not going to judge you. You know, I'm not going to criticize you. I'm not going to lecture you on that. You know, my goal is always to, you know, is always going to be, you know, what can we do to help you succeed? You know, what's the best thing that we can do for you in this situation? So, you know, so please, you know, I'm really asking you guys, you know, please don't cheat. You know, use me as a resource, you know, before that, because, you know, I want everyone to come away from this class with something valuable, and, you know, I'm here to help you guys. So, you know, please give me that opportunity, you know, before, you know, any foul play happens in the class. Okay, so the last thing I want to talk about on this slide is our first homework assignment, which is our email introduction. So a lot of you guys have sent me this already, so so thank you for that. But one thing I really like to do for the class is I really like, you know, to get to know all of you guys. You know, and I think that's going to be especially important now because, you know, we're not going to have the class where I can see you guys every day. So what I do for all my classes, I have the first homework assignment be to just send me an email to introduce yourself. And, you know, it doesn't matter what you write in the email. You can just say, you know, this is my name, you know, and that's, you know, you'll still get full credit for it. But, you know, of course, you know, the more detail that you put into it, you know, the more valuable it's going to be for me. And, you know, what I really like to hear is, you know, what kind of career and, you know, what you want to get out of the course. Because, you know, even though this is a course that I've taught before, you know, I know that, you know, every time that you teach a class, it's going to be a little bit different than before. just because, you know, the students are always going to be different. So, you know, I always like to tailor my class a little bit and kind of modify, you know, some of the examples that I do or some of the, you know, homework assignments that I give you to be, you know, more interesting and more relatable to you guys based on what you send me in these email introductions. So, you know, I really do enjoy these, and I personally read everyone, and I personally respond to everyone. So, you know, please, you know, send me these email introductions, and just so we can kind of get to know each other. So the due date for this is going to be 11:59 p.m. by this Friday, August 28th. But, you know, the sooner you get this to me, the better. So please send me this, you know, before the end of the week. And, you know, just like we talked about before, please include EGME 333 in the subject line, just so I know what class you're in. For this assignment, especially, it helps a lot because, you know, when I'm going in the grade book and entering, you know, the grades for this, it's really easy to sort just by 333, and I can see just all the names just pop up, and I can just give you guys credit for that. So, so please make sure you add that in the subject line. Okay. Okay. Are there any questions on this on the syllabus before we? So the next thing is I want to give a tour of the Canvas site, just because I know it's kind of a new thing for everyone. But before we do that, are there just any questions about the syllabus or course policies or any of that?
Someone had asked about homework assignments or whatever and scanning documents.
All right. Are there any other questions on the syllabus or the course policies before we take a tour of the course website?
No, I think Zoom started crashing for everybody because I just got kicked out and jumped back in as well. So
yeah, that's kind of what it seems like. So so yeah, I think definitely it would be good to have a backup plan. So I will definitely look into that for Wednesday. So the meetings is being recorded. So hopefully the recording will be in decent quality. But you know, it's so that'll be uploaded on YouTube later. So anything that you missed because Zoom crashed or something, you can definitely check out the YouTube video for it later. Okay. So there's no more questions. I think you know, we have 10 more minutes, but I think that's kind of the perfect amount of time to tour the course website. So let's go ahead and do that. Okay. So I think, you know, since I think for a lot of for a lot of you guys, I think this will be the first time you're using the Canvas website. You know, we've used Titanium up to this point, so I kind of just generally wanted to talk about you know, what you can how to find different things on the website and you know, how to go about navigating this. So there's a question in the chat of where do we upload the homework? So the homework will be uploaded here on the course website. And I'll basically show you how or where to. So I don't have an assignment now that uploads a PDF, but I will show you basically the tab on where to go and you know, what you can generally expect for the homework upload. Okay, so here's the course website. So I have it on student view. So this is hopefully what you guys see once you join the website. So this is the course homepage here. So my idea with the course homepage is to try to keep it as kind of brief as possible. So try to keep kind of all the important information, and to have, you know, a lot of the other information and other clickable links. So at the top right here, you can see, you know, here's my name here, and here's my email. So you can see this link is clickable. So if you want to know more about me, there's a little bit of a blurb here, but I'll let you guys, you know, do that. So here you can see a description of the course. Here's the learning objectives. Here's the syllabus that you can download. And so here's all of our Zoom links. So here's the lecture. And so here's all the office hour Zoom links that you can find here. Okay? And so, you know, we talked about the Discord server earlier. So if you click this link right here, it'll basically, you know, and you're logged into Discord, this will basically, you know, have you join the Discord server. So definitely make sure you do that. Okay? And so I think the main point of navigation is going to be this table down here, which is the course outline. So you can see right here, the first week is clickable. So this is, you know, you can click this and it'll take you to a different page. And what this will show you basically is kind of a brief description of you know, what we're going to be covering this week, all the learning objectives for the week, and all the relevant links and files that you'll see here. So you can see that we have one homework assignment due this week, and that's homework 0. Okay. Once I upload the lecture, the links will be here. Okay. And all the lecture notes and all the files, all the homework solution study guides, this will be listed here as well. So this will kind of be your first, this kind of week viewer here will kind of be your first stop shop to kind of find out what's going on for that week. So all the notes that you'll need for this week, all the recorded lectures from that week, all the assignments due that week, you can find it from these week viewers. So this is kind of be your first stop shop here. And so as we go about the semester, you know, all these weeks here will be clickable. So I basically prepare these pages kind of a week in advance. So by Friday of this week, you know, you should see the week 2 for hydrostatics will be clickable, and you can click it and kind of go into that week and see, you know, what we're going to learn that week and all the lecture notes and the videos for that week. So this is kind of be your first stop. This will kind of, this weekly organizer here will be kind of the main kind of organizing thing for the class. Okay. And so the next tab that you see here is announcements. So this is where, you know, all the course announcements are going to be. So I basically use this feature, you know, when I want to contact the entire class of something. And so, you know, every time I make an announcement here, it basically sends you an email about it. So, you know, if you read the email, you know, this is going to be no different. But if you want to see kind of a summary of all the announcements, this is kind of the place to go for. Okay. All right, so the next tab here is assignments. And so, you know, the question earlier about, you know, where do we upload assignments? This is basically where you're going to go. And so basically this will list out all of the homework assignments that you will have for the course. Okay. So if you click on an assignment, you can see a description of it. And, you know, for all the problem sets, you know, there will also be a link to a PDF that you can download with all the problems. And then from here, there will be, you know, a place where you can upload your homework, your homework problems, you know, once you finish them. Okay. All right, the next tab here is grade. So this is basically where you'll go, you know, that'll basically summarize, you know, all your scores for your homework assignments, your midterm exams, and your final exams. So basically, once I finish grading something and finish giving you feedback, it'll be listed here. Okay. So right now there's not much. So there's only the introductions, which is in the homeworks category. Okay. But you know, the midterm exams and the final exam grades will be here as well. And if you ever forget kind of the breakdown of the course grades, you can see it here as well. Okay. The next tab is people. So you can see the list of everyone in the class here. Okay. So if you want to, you know, contact, there's, you know, a certain person you want to contact, you can find their contact information here. Okay. And then the last tab that we'll look at is files. So this is probably the other really important tab here, because every PDF and everything that I upload for the class will be put into this files folder here. So you can see that the syllabus is already here, and I've created folders for, you know, homework assignments, lecture notes, live lecture notes, and any solutions. So like all the homework and exam solutions will be in this folder too. So if you want to just find, you know, where it's the, you know, what's the homework PDF, or, you know, where's the lecture notes PDF, you know, for a certain week, you can just go in here, right? And then it'll be available here for you to download. Okay? So definitely, you know, if you're looking for a specific file that you need to download, you know, this is probably the best place for you to look, is in this files right here. And it's, you know, and I've organized this just that, you know, everything is in folders right here. Okay, so are there any questions on the Canvas site? Hopefully it won't crash when I stop screen sharing. Okay, good. Okay, so if there's no questions, oh, the book, yes. So the book is on the syllabus, but I know there's some people here that's on the wait list. So let me pull it up. Okay, so here's the textbook here. So it's called, it's weird. So the author is Gerhardt, but the actual title of the book is Munson, Young, and Okishi's Fundamentals of Fluid Mechanics. So the reason the name of the textbook is so weird is because these three guys here were the original authors of this textbook, but then they must have realized that the textbook industry is the mafia, so then they kind of gave that up, and now there's a different set of authors that are editing the textbook. So to kind of give homage to the original authors, they put their names in the title. So the name of the textbook is Munson, Young, and Okishi's Fundamentals of Fluid Mechanics. It might be on a different version. So it was the 8th edition last year, but it might be on the 9th edition now. But just like we talked about earlier, just find a cheap version of it. Don't spend more than $80 on this textbook. It's a good textbook, but it's not worth more than that.
There was a couple people on the Discord who posted that they have PDF versions of it.
Great, that's beautiful. Yeah, well, I can't officially because it's great. Remember, I'm not checking too much into the Discord server, but anything that you guys can share to help each other out, I think is great. All right, any more questions of just about the course in general, or just anything about the class that I can answer before we end for today?
I had a question about people that are waiting for the ad code. When will we get it?
Yeah, I did notice that our department admin sent us an email during the class. I didn't get a chance to read it, but I will double check with him, and then I'll contact the people on the wait list. Once I get information on that. Just to kind of give you just an inside view, I do know that they've had to make these courses a little bit bigger than they're used to, just to kind of just because we had a lot of budget cuts this year because of COVID. So I do know that one thing that they're trying to do at the department level is to kind of balance out all the students between all the sections. So I think what might happen is that if there's kind of space on the wait list or space in another section of the class, they might ask you to move to that class just for just to kind of balance things out. But if it gets to the point where there's a wait list on every class, then I'll try my best to add everyone from the wait list from the class. But I will talk to our department admin and get back to you about it as soon as I find anything out. Yeah. Okay, so the class is done. So I don't want to keep you guys anymore. So thank you everyone for tuning in. So that was our first virtual lecture. A little bit of technical difficulties because Zoom is probably flooded with lectures right now, but hopefully those will be ironed out as the semester goes on. So thank you everyone for tuning in, and I'll see everyone on Wednesday.
Thanks, Dr. Tran. Appreciate it.
Yeah. Have a great day, everybody.
You too.
So if you guys have any other questions, I'll stick around for a little bit. But there's also office hours right after this, so definitely feel free to jump in on those as well. But I'll stick around until probably around 55 if you guys have any more questions. So the link is going to be on the homepage of the course website. Are you in the class, or are you on the wait list for the class? Because I know if you're on the wait list, you don't have access to the Canvas site. Okay. Okay, great. Yeah. So if you wanted to pop into office hours, I'll see you in a little bit. So the other courses I'm teaching this semester are EGME 401, which is the engineering economics and professionalism class. And then I'm also teaching a grad course in finite elements, so that's EGME 541. But in other semesters, I've taught courses like 308. I actually haven't taught 308 in a while, so I might request that for next semester. I also teach the 410 class, which is the elective on finite elements. And I like to teach courses that involve computation. So like last semester, I taught 417, which is the elective on computational heat transfer. And then, you know, anything involving fluid mechanics, I like to teach as well. Yeah. I've also taught heat transfer once too, but that's a little bit outside my wheelhouse. So that's not something that I'll request too often. Yep. Thanks, you too.